welcome to episode 220 of CXOTalk. I'm Michael Krigsman. I am an industry analyst and the host of CXOTalk. And right now, there is a tweet chat going on using the hashtag CXOTalk. I want to thank Livestream for being a huge supporter of CXOTalk. Livestream is great, and we love Livestream. So if you need video for live streaming, come to Livestream. And our guest today is Cham, who is a partner with Bloomberg Beta. And we're going to be discussing artificial intelligence, machine learning, and related topics, particularly from an investor's perspective. Cham, how are you? Thank you for being here.
I'm doing well. Thanks for having me. It is always a miracle that that live streaming works as well as it does.
It is. This is episode 220, and
wow,
I never expect that the whole thing is going to go through, but to the end. But in fact, it does.
That's great.
So James, tell us about yourself and tell us about Bloomberg Beta and what are you guys doing over there?
Sure. I'm a seed stage investor at Bloomberg Beta. We're a $75 million fund where we're investing in the future of work. And I'll tell you about what that means in a moment. But first, let me tell you about what I was like in the first grade.
Perfect.
That's just I've been a venture investor for the last 10 years. And before that, I was a software developer. And I think that there's the sense out there right now that, for all of the hype around sort of the future of the world, there's still a lot of hard work to be done. And on our side, as venture investors, our goal is, to be honest, is just to provide a little bit of faith behind the people who are going to create the future. And I think as a venture investor, we're most excited about finding people who are going to build the future. And our specific core thesis is around the future of work. And the insight is that with any new technology, whether we're talking about railroads or we're talking about electricity, it takes a few generations of managers to figure out exactly what to do with the technology. Because even when something starts to work, it's not that useful until people figure out what to do with it. And so we are now here 20 some years into the ubiquitous network computer. And we're at the point now where managers and organizations are figuring out how to use this technology in order to actually improve the economy. And so here we are, and we're feeling quite excited.
So you are very focused on machine learning and artificial intelligence. You and your partner came up with a market landscape of machine learning, but you mentioned future of work. And so can you maybe link together for us this notion of future of work and AI and machine learning and similar technologies? How do those intersect?
Sure. It comes out of, sort of when we first pitched this idea of investing in the future of work 3 or 4 years ago, there were a couple of key claims that we made. And I'll just walk through a couple of the other ones before I end up with machine learning. The first is that we live in a world now where everyone is a knowledge worker. And in the case where, the line cook down the street has an Android phone that is more powerful than the, first 10 PCs you bought, then he's a knowledge worker. He's able to capture information and manipulate it in all sorts of interesting ways. And when that's true, we should look at the best knowledge workers in the world and copy their tools and techniques. Now, it turns out that there's a class of people out there who use knowledge in interesting and clever ways. They're quite lazy. They're total introverts. They don't like talking to other people, and they like working on systems rather than practical applications. And those, of course, are software developers. And as a software developer, I've recognized when I worked as a management consultant that I could easily be 3 or 4 times more productive than an average colleague, in part because I understood what could be automated, and I understood a way of thinking about the world that lent itself towards a certain type of automation. And so we invest a lot in software in companies that are using software development methodologies in different industries. And so imagine bug tracking for the construction
Right.
world. Yeah.
So how does this all? But so then, how did you end up getting involved in machine learning, and what's the link to machine learning?
And so that so that was one key way that things were changing. And the other key way that things were changing is we saw 4 years ago that machine learning, which was an AI in general, which was so out of fashion for so many years, we saw glimmers that as both the technology was getting better and as teams were figuring out how to use it in the biggest, most advanced tech companies, there was a key sense that, oh, something is changing and maybe these things will be available to the rest of the world. And so we started poking around and started to try to make maps. And, my colleague Siobhan would say that, the nice thing about making a map is it doesn't have to be perfect. When you start making the map, everyone starts complaining to you and you end up becoming the center of the conversation. And when that happens, then it's the best way to learn.
So so you created this map and you have an overview of the machine learning industry. And what did you learn from creating that overview? What were the key themes?
What was interesting is now we've done this exercise 3 times. And the first time we did it, the term AI and machine learning was out of fashion. So people would hide the fact that they were doing something that you might want to call AI. And so even though Facebook and Google and Amazon were making all sorts of interesting investments, all the various startups that were working on AI-related things were kind of quiet about it. And so when we made the first map, it was interesting to see because we'd have to do a fair amount of digging in order to identify interesting companies. And then 2 years ago, when we put the map together, you saw the beginning of the feedback loop where a bunch of startups started saying, and a bunch of clever entrepreneurs realized that there was something interesting around machine intelligence. And so as a result of that, they said to themselves and they said to us, oh yeah, we're an AI company. And sometimes they were and sometimes they weren't. But it started to make sense as a buzzword for early stage investors. And what was most interesting last year, and this was sort of like the big surprise, and this was fairly quick, is last year when we made the map, all the corporates, basically all the big companies and all the sort of, all the folks who have huge budgets were suddenly interested in machine learning. And so we found ourselves in a place where, although folks weren't sure exactly what it meant, and they weren't exactly sure how they were going to use it, everyone kind of wanted something around AI. And so puzzling that through, I think, is the interesting exercise we're in right now.
Now, you talk about machine intelligence. And so why do you prefer that phrase?
So I forget if we talked about the history of artificial intelligence as a term, but it's a 56, 57-year-old term. And it came out of the desire of a set of computer science researchers not to use the term cybernetics because no one knew what it meant. And so I think on our side, and artificial intelligence is one of these sort of beautiful concepts because you feel like you unlock so many possibilities. But that's also a terrible thing from the point of view of a technology or startup, in part because inside AI, you find embedded a whole set of metaphysical questions and concepts about what it means to be human or not human. And so those sorts of questions, although I enjoy talking about them at the bar or over dinner, are less useful as we make decisions about how to invest and as organizations think about investments. In part because, what is artificial and what's not artificial? And, you end up with sort of the mind ends up drifting off into something closer to science fiction. When machine intelligence captures this sense that we are just trying to say, what are ways that both machines and systems can be slightly more intelligent today and work with us in clever ways? And so we found the term machine intelligence to be something much more helpful, and it focuses the mind.
So the point is to help people, basically non-technical people as well as developers, stay focused in the direction of practical applications of AI?
practical 5 to 10 year questions, but also less metaphysical ones. I think, questions of uh, uh, even developers love talking about, sort of, does this mean that the end of the world is coming? Or, does the singularity represent the apocalypse? And I think those are, important, genuine discussions, but in some ways they're less helpful for our purposes day to day.
So there's a tendency for people to want to kind of dive into the metaphysical aspects of AI, which is can we say, a distraction from focusing on the applications of AI and the innovations and where it might go during the next 5 or 10 years, as you say.
Yeah, we are seeing, we are seeing so much innovation and advancement on the technical side. And what's lagging is clear thought and understanding on the economic and managerial side. I think that the biggest risk for many, I think that the biggest risk for most of us right now around machine intelligence is less that the machines will take over and we will no longer have a job, but the biggest risk is that we as managers will make really bad decisions about where to invest, and we'll end up wasting billions of dollars on stupid projects that nobody ends up caring about. And I think that in some ways is the immediate, interesting, obvious question ahead of us for the next 5 to 10 years.
Okay, so you left me the perfect opening to then drive through, which is, how should managers, what is the framework or approach for managers to think about the economic aspects and the organizational implications, managerial implications of AI and machine learning and similar kinds of technologies?
Gosh, I'm glad you asked. I actually think that this is still a poorly understood and badly researched part of the question. For the last couple of years, I've been wandering around talking to various economists, asking them, so, tell me, what is the right microeconomic framework for thinking about how to invest in machine learning or around AI? And I think in general, most economists and most business school types are still more focused on the larger scale economic implications. But those larger scale economic implications don't really matter unless we make good decisions, right? Or unless we make sort of interesting decisions at a micro level. And so in general, the way that the pattern would work is I would ask someone and then they'd say, oh, it's really obvious. And then they'd be quiet for a long, long time as they thought through exactly what this may or may not mean. And there were 3 guys out of the University of Toronto in their business school who ended up actually coming up with what I think is the best framework for thinking about machine learning in general. I think that, for most organizations, the right way to think about machine learning is to think about the cost of predictions. In the same way that if you were to abstract at a certain level, computation, the history of computation is about reducing the cost of arithmetic. And when you make it really cheap to add and subtract at a certain level and scale, then you end up with, sort of digital cameras and whatnot. And if you think about AI as being different or machine intelligence as being different, and think about it as reducing the cost of prediction, then you apply the same sort of mental framework that you do for normal economic analysis. And you say to yourself, if the cost of prediction goes down, then what are the complements and substitutes to me? And what are the ways that I could sort of change my organization at its core? So that's the microeconomic way of thinking about it. And then there's sort of like the meat and potatoes, so what does this actually mean and what should I be counting and measuring part of it? And I think that we, for most IT organizations on the software side, we now understand how to manage applications and we understand how to manage data stores. We have huge inventories, we have great policies around how to build applications and how to roll them out. And we have good policies around how to manage data, although obviously we're now at a point where there's an awful lot of data and we don't know what to do with half of it, right? So that's well understood. Now there's this thing in the middle which doesn't really have a good name that some people are calling algorithms, or some people are calling sort of predictive frameworks. And that thing in the middle, which is to say a program that is generated by another program, right, by pulling in a bunch of data, like that thing in the middle, which I think I would call a predictive model, is going to be the core of most IT organizations, right? That, sort of, it's fine to have a data-centric organization, but if you have all this data and you don't know what to do with it, it's kind of useless, right? And it is good to have better workflows, but if the workflows just help you do the same thing over and over again, that's not that useful. If, on the other hand, you as an IT organization thought about yourself as model-centric, then you would think about all the processes you have inside the organization, and you say, which ones of these are valuable enough that I would want to make predictions and decisions without having people involved on a day-to-day basis? And I think, like, the exciting thing about those models is, one, I don't know, we're going to have a lot of them. Sort of, they're going to pervade throughout the entire enterprise, and that's the exciting part. The scary part is we have no idea how to build and manage them, because these models are totally different than, or they're not totally different. They are subtly different than applications. Because in the case of an application, I don't know, it's always amazing to me that applications work, because building software is difficult. But I at least have some idea how to QA and test it and how to deploy it in some consistent way. I have like lots of bruises, and as a culture, we figured out how to do that. Models, on the other hand, we don't really understand. We don't always understand, like, sort of, for some of these newer models, we don't understand how to think about them or how to introspect on them. We don't really understand how to test them, because even theoretically, if the model was totally testable, it wouldn't really need to be a model. And then we don't know how to deploy them in a consistent way, right? And I think that's the heart of, sort of, there's all the great sexy stuff, but for most organizations, as far as the things that they will have to build and manage themselves, it will be these models and understanding where to, sort of, where in the organization should I make investments and how should I think about it.
I want to remind everybody that you are watching episode number 220 of CXOTalk. We're speaking with James Cham. And if you are watching on Facebook, come on over to Twitter and join everybody should do this, should join the tweet chat that's going on right now using the hashtag CXOTalk. James, you were saying that machine intelligence lowers the cost of prediction. The question is, for managers, and we're talking about the decision-making around using these technologies in a meaningful way in business. But when you say it lowers the cost of prediction, will managers really understand the full scope of the implications? And how do you translate that into practical decision-making ability, I guess, as a way to put it?
I think that, of course, they won't. None of us really understand, sort of, when IBM started selling mainframes to Ford and, sort of redoing their accounting system, no one really understood exactly what that meant. They knew that it was better, and they knew that it was the future. And I think that it is dangerous. Okay, it is important for vendors and for visionaries to talk about the bright, shining future. I think it is dangerous for managers to get ahead of themselves. I think that we are at a point where there's still a lot of learning to be done. And as such, you don't want to do a big bang, right? Sort of, you are still at the point where there are processes inside your organization that right now, if you just go through your list of processes and started writing them down and thinking about the places where you are building workflow, or you had like interesting data sitting on the floor, sort of, that's like, you can start thinking there, and you can start saying to yourself, okay, in these processes, there are some decisions that are made that right now we just do automatically, right? Sort of, that either we do automatically or some person has to deal with it. And you should take those, which are oftentimes then characterized as business rules or heuristics, right? And those business rules are useful, but they don't really change, right? But in the new world where you can build a model, you could then have something that's much more flexible than traditional business rules. And I think that's the exciting thing. Down the street from where you are, so I'm here in sort of sunny San Francisco, but down the street from Boston, in Cambridge at MIT, in the mid 90s, there was a lot of talk about learning organizations. I don't know if you remember this.
Sure. Yes.
And learning organizations was always kind of a lie, right? Because organizations don't learn, people learn. Learning, organizations, sort of pull together some sets of, or people pull together some set of insights, right? And then if they're good, they remember those insights. If they're better, they might even write down those insights. And if they're best, they might change the organization in some way, either in the way that's organized or in specific business rules that are captured, so that they can remember those insights. But the organization doesn't really learn anything. The organization is this fiction of these people working together. But in sort of like a model-centric company in which we are able to actually systematically capture both inputs and outputs and sets of decisions, and we are try to build models that help automate those decisions, then you might actually end up with a learning organization where you actually could codify and capture the value that people get out of these decisions. And so I think that's like the exciting future. But I will not claim that I've got I don't know, I would have stayed a management consultant if I were to try to claim to you that I had a systematic way to get there.
So right now, organizations what advice do you have for organizations that are looking at AI, and how do you assess the state of adoption? I'm assuming this, given that you're investing in companies, machine intelligence companies, you must have a real interest in the uptake and adoption of AI in the enterprise and also in the consumer world as well.
So maybe let's tackle the adoption question first. I think that there's a joke that some AI researchers will make around the history of robots, and they will say, we're constantly talking about how robots haven't hit the mainstream, and then they'd say something like, well, the truth is that robots totally have hit the mainstream. It's just at the moment they become mainstream, we no longer call them robots. A researcher friend of mine showed me this advertisement from the 30s about these amazing robots that were called toast-making robots, right? And then it's just at the moment you can consistently make toast with these robots, you'd call them toasters, right? And so I think that the adoption of AI-related techniques and machine learning-related techniques, the moment they become interesting, and then the moment they become interesting, everyone talks about it as AI, and then they don't quite work. And the moment they become mainstream, then no one talks about them as AI anymore, right? And so, but I have a relatively simple test for organizations as far as just figuring out how much that they've adopted a machine learning or machine intelligent mindset, and that is if there are senior technical people who have threatened to quit because they're so unhappy with the reliance that the organization is making on machine learning, then that is a good sign. Because at its core, an awful lot of machine learning models go antithetical to all the things that I learned as a software developer, right? Because I am now trusting a bunch of probabilistic models in ways that I should never have before. And I'm also now unable to understand at its core, to dig into all the actual instructions to understand whether something's actually working or not. And that is a huge cultural shift. It is incredibly difficult. And so whenever I then talk to a data science team at a big company or a large corporation, if the corporation tells me that, oh yes, things are going really well and everyone's really happy, then I immediately assume they've not done any of the actual hard work, because it is really a shift, because if you assess the data science organization in most corporations, it's either going to be engineers who don't really understand statistics, or it'll be statisticians who are, from the point of view of a software developer, really slow, right? And sort of that synthesis is yet to happen in most places.
So, what is it about machine intelligence and these various derivatives, machine learning, AI, deep learning, cognitive computing, and so forth. What is it about them that has these profound implications for society, for culture, for organizations, as you were just describing? Why are these technologies, and in what ways are they different from traditional software?
So, at their core, we as software developers are giving up an awful lot of control, right? Because rather than writing and codifying in systematic ways business rules or understandings of schemas, we are giving up some of that control to other algorithms to generate decisions that we would think that we'd want to make ourselves. And I think that is actually quite difficult. It reminds me in some ways of, you asked me earlier, how do I assess or how do I think about, how do I assess machine learning startups, or how do I think about that right now? It was true probably 3 or 4 years ago that I'd be looking for people who came out of the best research labs or people who came out of some of the companies that have actually been running, sort of large-scale machine learning projects for a while. And while that's still true, the interesting shift on my side is that I'm now looking more and more for people who are trying out different business models, because the first step is to write software that is probabilistic and that you will sort of trust to do a bunch of different things. That's the first step. The second step, which is still poorly understood, is, so what are the actual business implications for this? How does this actually change the economics of my business? How should I be charging my customer differently? How do my moats get developed differently? And on that side, I actually spend a fair amount of time talking to people who then have been trying to run machine learning related businesses for the last few years. And I think that's there are a lot of open questions around that. Sort of one interesting example is, if you ever think about traditional SaaS. Okay, it's weird to say traditional SaaS, right? SaaS has only been so popular for the last 10, 15 years. But if you were to think about most great SaaS companies, they've spent a lot of their time convincing me as a customer that my data is safe in their cloud, which really just means their servers, right? So I now trust them, and they've spent a lot of time convincing me that this is both cheaper and more effective, and also that my data is safe, it's protected, which is sort of why you have there's an awful lot of technical architecture talk that really is just marketing to convince me that my data is safe in your servers. So that's interesting, right? But in a machine learning world where the data from different customers is actually, sort of all additive, traditional SaaS companies have a hard time telling me that my data is going to be used by another customer, right? And I think that shift in thinking about how the business is run and my relationship to my vendor is something that an awful lot of SaaS companies are going to have a hard time with, in part because their terms of services sort of assume that, their data was never designed to be folded into someone else's model. And so that's an example to me of some sets of changes in how business will be run for software companies, and changes that we don't understand yet, right? And that we're just figuring out.
What about the changes that are implied for companies? I mean, for example, you're so focused on the future of work, and yet the moment you begin to connect machine intelligence, artificial intelligence to the future of work, a lot of people become very concerned about their jobs. Yeah,
I think that's so let me, I think there are two interesting angles on that. So first, these models are not perfect, right? These models, the interesting thing about these models is, sort of there's never the illusion that they'll be perfect. The data that goes into them sometimes changes. The actual problem that they're trying to solve changes. As a result of them, that the models constantly have to iterate. And, sort of when we call it machine learning, there's this illusion that the models get better. They don't necessarily get better. they just iterate. And when they iterate, sometimes we're hoping to get better, and we need to have ways to understand that, right? Because, if you were to think about, a big bank that builds a better and better model, right? If you're not careful, one day you might find that you're accidentally redlining, right? And then you're incredibly racist and you get in a lot of trouble. And sort of that understanding that these models shift is a big open question. And so there's going to be a lot of work. There's going to be a lot of work around managing models and building new models, because when you have lots of models, then the nature of competition also changes, because now you're building models to compete with other people's models and things like that. So that's the first piece. And the second piece about the future of what my work actually looks like. There's this guy, Hal Varian, who is currently the chief economist at Google, and for a long time was at Berkeley. And he once told me this story when I asked him about something very similar to this. He said to me that, well, if you were to talk to my grandfather and he looked at what I did, Hal's I think he's from the Midwest. His grandfather's a farmer. He'd say my grandfather would look at my work and say, "What are you doing? You're fiddling your fingers all day, right? You're not actually working. You're just twiddling your fingers on this weird chiclet that looks like maybe a keyboard." And that's because what Hal's doing now, or what we all do as knowledge workers, looks fundamentally different than what we would have thought of as work, even 50 years ago. And I think the same thing is going to be true for the next 10, 20, 30, 40 years. That, you're going to go and talk to your grandkids, and you're going to see whatever it is that they're doing, and you'll say, gosh, are you guys working, or are you playing video games, right? And I think just the nature of work changes, and the thing that's hard to appreciate right now from where we sit is how dynamic and how quickly the actual nature of work changes. So I think that's the good news. The good news is that people will find things to do and find new problems. You have so many things out in the world that need to be solved. So that's the good news. The bad news is the shift. The shift is really fast. And I don't think any of us have an idea of how fast or slow it's going to be. And if shift is too fast, historically, people figure things out ultimately. But sometimes we end up with huge upheaval and wars, right? Because people don't know how to manage it. And so I think that question is going to be probably outside the scope of this conversation, but I think that is one of the more important questions of the age.
Yeah, clearly there are going to be public policy implications, and we've been having some of those discussions with experts in ethics and public policy here on CXOTalk.
Let me just say one quick thing about that, though. Mm-hmm. It is hard, though, for the ethicists and for the public policy people to talk about this right now, in part because even managers on the ground don't totally understand how things are changing. And in some ways, my biggest, one of my biggest side projects is this effort to connect economists with actual practitioners right now in machine learning and MI, because their understandings are totally different. And they're, the practitioners would actually benefit a lot from talking to economists and people who have theory. But the folks who have theory, the theories need to change based on what's actually happening on the ground. And there's actually still a huge disconnect at this point.
So you're trying to connect economists who are focused on machine intelligence technologies to, when you say practitioners, how do you define the practitioner in this case?
I'd say that in a lot of cases, the economists around who are thinking about machine learning haven't spent enough time with the guys and gals on the ground, actually building models day to day, understanding how hard it is, what's easy and what's not easy. And I think that there are lots of open questions about that right now.
And what is the...
As an example, the algorithms are not magical. The thing that is magical is getting a bunch of data and cleaning it and normalizing it in a way that's usable. That's magic. And the other part that's magic is, there's a lot of fiddling that you have to do with these models in order to get them to be effective, right? There's just a lot of when I say fiddling, oftentimes literally there's fiddling. How do I deal with this feature or that feature in order for my model to actually be predictive?
I think this is a very important point. When you say that the models are not magic, the algorithms are not magic, can you elaborate on this? I think this is a very important point for people to understand.
Yeah, I mean, I think that it. Oh, well, okay, so it's a little bit worse than that. One, they're not magic because it's sort of there are a number of well understood approaches that people have had for a number of years around how to try to build these models. But two, it feels like magic because we don't understand it yet. It feels like magic because the theory has not caught up with the practice, right? That sort of if you were to look inside even sort of academia for AI, there's a huge disconnect between the people who are building new algorithms and new approaches and with the guys who build good theory. And the folks who build good theory still don't really understand, exactly what's happening right now.
But then you said that the data is magic, the collection of the data, the cleansing of the data, all of that. So why this distinction in this way between the algorithm and the data?
Because the data, I think that I imagine most of your audience has at some point, put together some great software product that totally failed because the data that they stuck in it was bad, or that someone misunderstood some column, or someone misunderstood the nature of the problem, right? And so that's always a problem. But that's a problem when like you have 1,000 rows, and it's a bigger problem when you have 10,000 rows, and then it's an enormous problem when you have like hundreds of thousands or millions of rows. And so that process of cleaning that data is still quite difficult. And understanding the problem you're trying to solve, that's still quite difficult. And then figuring out if the data that you have actually relates to the problem you think you're trying to solve, like that's even harder, right? And so we're still, in a lot of these model building cases, still at that point.
What are some of the use cases that you see that are most interesting around all of this?
I mean, it's every. So I don't want to now. I try very hard as an investor not to get too either too visionary or too optimistic about things, but I don't know. It hits everything, right? It hits everything from things as mundane as so I shouldn't call them mundane, but things as mundane as looking through people's expenses in order to capture examples of lack of compliance. So I'm an investor in this company called AppSend, which does this. And on the one hand, you'd say, "Gosh, James, this is a really boring problem. Who really cares about this?" And then, and I kind of said that to the founder at first. But then the moment they go through and do a little bit of analysis to look at like how many cases of non-compliance you get in, and when I say non-compliance is either malicious or not, right? Sort of in expense reports, it's tens of millions of dollars. And it's one of those funny things where it's just like this little problem sitting on the floor that was not practical to deal with before, just for organizational reasons, because you'd have to hire lots of people to deal with it, or you had to outsource it, which would be like complicated. But now when you can figure out what are the things you care about and then rely on AppSend to come up with the sort of the little bots to scrape through all the data, like it's then become the cost of prediction goes down dramatically, and suddenly this thing, which was one of these little nagging little things you were worried about in the back, now becomes something that you can immediately practically solve, right? And then so it's things like that. It is things like there's a company out there right now called Textio that goes through and reads the resume, the job description that you write, and goes through and says, you know what, statistically, when you write the job description this way, you're less likely to get people to try to fill it out, right? And that sort of like long-term conscientiousness and memory and remembering every job description you've written in the past, like no one's able to do that, right? And so by putting together the collective wisdom of everybody, it's kind of amazing, so, which is just to say, I think we'll be surprised by how much the enterprise can change as you start to understand the potential around machine intelligence. So it's like all the big strategic things and all these little parts of the company that fundamentally will change. The difficult part, so this is the caveat. The hard part is that we don't know, or we don't have good ways yet of predicting how much these models or these bots will help the organization. That we don't have good intuition around saying, if I try to go after this problem, maybe I'll save this much money. There's a MIT professor who I was talking to the other day, who's been doing this for the last 20 years and in a different field. And he said that the hard part for him, so in his case, he was doing compiler design. And he said the hard part would be he'd apply machine learning to one specific problem, get almost no results. He's like, it improves by 5%. I don't really care. And those would be all the problems that he thought he knew about, right? But the moment he started playing with it on larger and larger scales, he'd be surprised to see that, this problem, which I didn't even think of as a problem, I can now solve because it wasn't in my head. I didn't think about this thing as something that was even solvable. And so that's the exciting.
So we don't yet have enough experience with the long-term implications of these technologies, these algorithms, these models to know what is going to be really important and make significant changes. It's still too early, essentially.
There's a lot of playing that has to go on, right? I think there's a lot of playing and a lot of sharing of knowledge and learning. There's got to be a lot of entrepreneurship, both inside big companies and outside in my part of the world, right? And I think that's the interesting cutting edge that goes under discussed. Because everything else is true, right? All the sexy techniques, all the new ways that people are coming up with to solve some of these model building problems, all those are really important. But I do think that we need to spend more time asking the questions that I'm asking.
We have just a few minutes left. And one of the issues that comes up is there's just so much hype right now. Pretty much every technology company these days says we have AI in our product. And I'm sure sometimes it's true, but probably there's a lot of bullshit going on out there at the same time. So how do we distinguish between the hype? And this is effectively, in a sense, is a key part of your job, right? How do you distinguish between the hype and the reality?
Okay, so there are two different questions. If I were a manager right now, what would I be doing, sort of to try to figure out what worked or didn't work? I'd be doing probably three things. I would be, I think this is a great excuse to buy all the consumer electronics that your wife doesn't want you to buy. I think this is a great time to be playing with Alexa and to be playing with various tools, just to start building intuitions around how you feel about things and what seems effective or not effective, because there's a lot of uncertainty. So that's one. This is also a great time to look on the smaller end around making sort of little investments around products that claim that they'll solve something for you, right? So I think that there are lots of tools that are in the $1,000 to $2,000 range per month, which you should just start playing with to see whether or not you can build an intuition. But the thing that I spend the most time on is I would start getting to know the data people inside your organization and figuring out what are the secret things that they know are not accurate and things that they know that are accurate, and just sort of digging inside the organization to figure out what are the opportunities for us, because there are going to be opportunities that are going to require, sort of hugely expensive models to build, and there'll be some very low-hanging fruit. Some very, very low-hanging fruit. And I think once you adopt this model-centric view rather than application-centric view or data-centric view, then I think you see your company a little differently.
So become friends with the data scientist in your company.
Either the data scientists or just the database guys. There's, they're sitting, and the guys who are managing various logs, and I think you'd be surprised what's available.
So we live in a data world, increasingly so, and so therefore learn about data and talk with people who are involved with data of all kinds, essentially is what you're saying.
Yeah, because we're also in this migration from a data world to a model world. And I think that transition, I do think that the companies that do that best or figure that out sooner are going to be the ones that are going to be, I don't know, imagine all the buzzwords you love, like agile or dynamic or whatever, just like those good things. Like the ones that are model-centric and are smart about being model-centric are going to be the ones that are going to be successful.
So it's no longer just about business model, but it's about understanding data models and the algorithm models in connection to the business model.
Right, right.
That's the new linkage, is business model, how business model and data connect.
That's right. That's right.
Well, that's a pretty interesting topic, and unfortunately we're out of time, but how about come back another time to CXOTalk and let's explore that one, because that's an interesting one.
Yeah, I think that's a big question. I think that is a big question. You know, okay, so I'll have to stop. I'll have to like at least leave you with like my current favorite story, which everyone should now look up. Everyone should look up. I think probably your entire audience has heard about AlphaGo, and you know, and it's super impressive. I don't really know how to play Go, so I had no deep insight there. But the, you know, sort of the interesting angle to me is less that the machine beat sort of the best player, some of the best players in the world. The interesting angle is if you were asked the players, they'd say that, oh, the machine introduced strategies that we've not yet thought about, right? That we've not yet understood or considered. And in some ways, one like the better enlightened version of machine learning, the world that I hope we end up in, is one in which, you know, sort of our small understanding of what the problem set is, or the solution spaces, actually gets expanded, right? Because we're now able to rely on machines to help us explore different types of solutions that we haven't thought about before. And I think that's the exciting part.
What's new? What's new? What it enables us to do that we couldn't do, that we didn't even think about.
Right. What strategies, you know, what different types of problems can we solve that we haven't even thought through yet? And I think that the managers who start tackling the basic things now will, over the next generation, be able to tackle these bigger ones.
Well, that is hugely valuable managerial advice. Thank you so much, James Cham, for being our guest today on CXOTalk.
Great.
You have been watching episode number 220 with James Cham, who is a partner at Bloomberg Beta. Thanks, everybody, for watching, and we have another great show next week, so please join us. Bye-bye.